So my name is Liz Woodham, and I'm joined today by
Charlie.
And also by Ems, who's the director of NRICH. Hi, Ems. And the three of us will be leading the session this afternoon. We must, before we start properly, thank Trinity College here in Cambridge for funding our webinars, and so they are free to you. We're going to be working on various tasks throughout the session, and so we will be inviting you to do some mathematics with us. And so please do use the chat as we do that to contribute your ideas and thoughts. And in fact, do ask any questions in the chat as we go. A quick reminder, if you wouldn't mind keeping your cameras off and your microphones muted, that would be really helpful. Okay, so I'm going to start by sharing a tab on NRICH. We're just going to give you a little bit of background before we start doing some maths. Oh dear, I'm making a right hash of doing this. Let me try again. You'd think by now I'd be able to do this really quickly, wouldn't you? Here we go, hopefully. Right, I'm hoping that you can see on the screen an image of a rope. And those of you who have been to our webinars before will know that we talk about this Kilpatrick rope model as a framework that we use as we're creating NRICH resources. So Kilpatrick and colleagues talk about the characteristics which make a good mathematician. And so in the classroom, this is what we're aiming for. We would like students to have good conceptual understanding and be able to use ideas fluently. And we also want them to enjoy doing mathematics, so to have a productive disposition, to realise that it's worthwhile putting a lot of effort into our mathematics. If we try harder, we can succeed in maths, and we are resilient and enjoy working with other people. And in addition, as we look at a task that perhaps we've never seen before, we can apply some strategic competence. We've got some skills at our fingertips that help us to solve problems, and we're able to use our reasoning so that we can describe how we have solved the problem. Now, what we've done on NRICH is we've tried to structure the website so that you can find our tasks in a variety of different ways, which will help you build and develop these characteristics of good mathematicians, so that your students will be able to work mathematically. If I go from here, I'm just going to scroll up this page. And if you look at the top here in the, oh, you know what I should do is just log out quickly of the site. I should have done that earlier. I'm going to go to the primary teacher homepage. So here on our teachers menu, I'm going to click where it says primary teachers. And this takes us to our primary teacher landing page. And so I'd like to draw your attention to the way that we have designed this page. So the curriculum linked problems will take you to tasks that are organised via the curriculum objectives. And so that's how you'll be able to help students develop their conceptual understanding alongside their procedural fluency. If you're interested in particular in developing students' mindset, so this is about their disposition. This is about helping them to get better at working with other people, to be more resilient as they tackle mathematical problems, to be resourceful, draw on lots of different skills, and to perhaps develop their curiosity. Are they hooked in by mathematical ideas? This would be the area that you would go to. And incidentally, last time we led a webinar, we discussed working collaboratively, one of our mindsets. The third way that we've divided up our content is by mathematical thinking. And Charlie, I'm going to hand over to you at this point to give us a little bit of a talk through of how we've split up these ideas.
Okay, thank you, Liz. So yes, so in the rope model, we just had two threads, which were about mathematical thinking. So we had the two which were about conceptual understanding, fluency, we had the productive disposition, and then the other two, the adaptive reasoning, strategic thinking. And we decided that it made more sense to look in a little bit more detail, to break it up. So we've got 5 headings instead of just the 2 from the rope model.
That's right.
And the reason we've chosen these 5 headings, which you can see on the left-hand side there. Let me just make my...
maybe.
Okay, so if we look at the headings on the left-hand side, we've started with exploring and noticing, because when you come across a problem that you've never seen before, and you're not quite sure what to do, then you get some paper and pencil out, and you've got to work at it and try things out and experiment, and it's what we refer to as sort of doing some messy work.
Yeah.
But in the process of doing some messy work, you might start discovering something or noticing something which you're then going to build on. So that's why we started with that. It can often lead on to working a bit more systematically when you think, oh, I think I've noticed something, and it might involve just changing one variable and seeing what happens, and or just testing something out in a more systematic way, which might then go on to sort of visualizing and picturing and what's going on. And we talk about multiple representations because you might think about it numerically, you might think about it geometrically, you might think about it algebraically. And this often leads to some conjectures and some generalizing, which often finish off with reasoning and convincing, coming up with convincing arguments, sometimes proving. So that's sort of why we got them in that order. And because of that, today, we're going to concentrate on exploring and noticing. And we're going to talk about 4 problems, if time allows. And I hope this is not going to frustrate those of you who are joining us. We're only going to give you enough time to do the exploring and noticing stage. And we're going to dip into all 4 problems, but we're not going to see the problem through to the conjecturing, generalizing, convincing and proving stage. Now, you might want to go off and think about the problems. You might want to go and work with your children, your classes on the problems, or you might just want to leave them to one side, because in future webinars, we may return to those problems and see how these original ideas that crop up today might be the springboard to to further mathematical thinking.
That's right.
So apologies if you're going to be very frustrated, but the idea today is to just spend some time focusing on that initial stage when a problem is presented and you don't know what to do, and you have some time and opportunity to try things out.
Yes, Charlie and I were talking earlier, and we were imagining, you know, a professional mathematician is working on problems that nobody has worked on before. So that sense that they are, you know, they are faced with situations that there is no, I think the word you've used, Charlie, was roadmap for. And we'd really like to give students that same experience by offering those opportunities to really pull together some of their own ideas and try things out themselves. So, shall we get going with the first task?
We're going to do 2 problems, aren't we? Yes.
Yes, we'll do 2 problems in quick succession, and then we'll reflect a little bit on them in terms of the exploring and noticing. So the first task that I'm going to show you it's a problem called digit addition. Now, if I was doing this in the classroom, I wouldn't necessarily put the task on the board and share that with students in the way that I'm going to do with you. But I think possibly because we're not going to spend very much time on this, it will be helpful for you to be able to see the task. So I think in the classroom, I wouldn't necessarily do this. So we're going to have a go at this together. So what I would like you to do, please, is think of a number from 1 to 10. You could choose 1 to 9. You could choose 1, you could choose 9, any of the whole numbers in between. Please, could you add 9 to your number? And now, could you add the digits of your answer together? So you'll have a new number now. And my question is, what do you notice? So do feel free to pop your noticing or your noticings in the chat. Just to go through that again, in case you were just temporarily distracted, you're choosing a number from 1 to 9 inclusive. You're adding 9 to the number, and then you're adding the digits of your answer. So you're left with a new number. What do you notice? Okay, thank you to those of you contributing in the chat. Charlie?
Everybody seems to have ended up with the same number that they started with.
Right. So straight away, what I love about this problem is that straight away we have got a noticing. Now, I guess the advantage of us working on this in a large group, Charlie, is I'm told by lots of other people that they also got the number they started with. So actually, it's not just one example from me, but and so we've got a noticing. What are we going to do with this noticing? I guess well,
this seems to be like it would be the springboard to lots of possible questions, like, is this always going to happen?
Yeah.
Why is this happening? Which goes into other mathematical thinking that we're going to be thinking about in future webinars.
Yes.
But it also, we might be conjecturing, I wonder what would happen if instead of adding 9, I added 19.
Right.
Or maybe instead of adding 9, I add 2 lots of 9. So if I added 18, what would happen?
Yeah.
So I might be, but also what would have happened if instead of starting with a single digit number, I'd started with a number between 10 and 20?
Yeah.
What happens there? It just feels like
lots of questions.
Yeah. So that initial activity, which was very accessible, raises lots of questions that students can then go off and think about.
Absolutely. And that's where we're really going to leave it for now. As Charlie said, there is lots of potential for this task, but that takes us beyond our exploring and noticing for the moment. So I wanted to get us going on something very accessible, which gave us some noticings very, very quickly. Lots of you, I know you wouldn't be able to help yourselves. Lots of you, I think, have automatically thought, why does this happen? And another reason for introducing this particular task to you is that there are accessible ways of explaining what is happening. This is not about needing to be able to express things algebraically. You could, but actually young children can begin to understand how to explain what's going on, just thinking about tens and ones.
That's enough about this problem.
That's enough about this problem. I like the way you're reining me in. Yeah.
There's a danger that we end up talking about the problem.
There is a danger. So Charlie, for the next problem, I'm not going to, no, I know what I'm going to do. I'm going to show an image for the next problem, but I'm going to invite Charlie to have a go at this problem. It's a little bit more tricky. It's going to involve a little bit more calculation. Are you up for the challenge?
You have me worried. Keep going.
Okay, so Charlie, this problem is called Make 37, and I want you to imagine that we have got lots and lots of ones, lots and lots of threes, lots of fives, lots of sevens. Can you find 10 numbers, ones, threes, fives, or sevens, that when added together make a total of 37? So Charlie's got some pens to figure with. I'm just going to change the way I'm sharing so that instead of sharing the screen of NRICH, I'm going to share Charlie scribbling. So Charlie, let's make sure we understand what we're doing, if that's okay. So we've got ones, threes, fives, sevens. You can use as many as you like of each, or you don't have to use one of each if you don't want to. Okay. So I'm hoping everybody can see threes, fives, and sevens. Yep.
And I don't have to use all the numbers, but I can use as many of them as I like. Okay. And I want the total to be 37.
37, please. Yeah.
So the target.
Yeah.
And I'm only allowed to add them.
Only allowed to add them. We're talking about a
Okay.
total. We're just finding a total.
Okay.
Yeah.
Well, I'm going to need, I don't know, 3 plus 5. I don't know.
By the way, if you've seen this problem before, try to hold off revealing anything if you can, please.
So far I've got 9.
What have we got there?
21, perhaps 31. 31 plus 3 plus 3. I think that's 37.
Okay, but how many numbers have you used, Charlie?
1, 2, 3, 4, 5, 6, 7, 8, 9 numbers.
Well, that's no good. Very close. But
Okay.
I asked you to use 10.
Exactly 10.
Exactly 10.
Okay.
Exactly 10. So I think Charlie needs a bit of help. Could you have a think about this, please? We're using 1s, 3s, 5s, and 7s. Can you choose 10 of those numbers, which when added together make a total of 37? We'll give you a little bit of time to have a play. If you do manage to find 10, if you wouldn't mind posting them in the chat, that would be super helpful. And after a few minutes, we'll come together again. I'm going to put myself on mute so that I don't disturb you. Those of you who are working busily away to try and find 10 numbers, perhaps if you're still finding some combinations, I would encourage you not to look in the chat at the moment. So we don't have any solutions yet. I don't think anybody has posted 10 numbers to make 37. This is a bit harder than we perhaps anticipated. Let me ask a slightly different question. All of the kind of the tries that you've had, of the calculations you have managed to do, is there anything that you notice, or what's the same about some of the tries? I wonder, we've got a few
Perhaps it's worth talking about what happens when we do this with students.
Yes. Oh, interesting. Thank you to those of you who are posting some noticings. Interesting. So several of you are saying that you seem to be able to get 37 with 9 numbers or 11 numbers. That's what happened to you, Charlie. You managed to do it in 9. Somebody else, 5 Acre School, somebody is saying they've managed to get 36 and 38 pretty easily with 10 numbers. But I like the way you phrase this. 37 is elusive. Interesting. So what's going on here, Charlie? I noticed that it seemed to be straightforward to get use 9 numbers, 11 numbers to get 37.
Well, there's a bit of me that doesn't want to give the game away.
Why can't I hear it?
It's some people have figured out what's happening.
Yes.
And that's what, as a teacher, you might bring ideas together and so on. But with students, my experience is they work on this for 20 minutes, half an hour, determined to find 10 numbers at work. But what's really nice is that when you bring students together and they notice what teachers have been noticing, which is that you could do it with 9 numbers, you could do it with 11 numbers, or you could get 36 or 38, that there must be a reason behind this. And so this is, again, the springboard to some conversations about, well, what happens when you add 2 odd numbers? What happens when you add 3 odd numbers? What happens when you add 4 odd numbers? And I sort of don't want to say anything else other than putting students in this position where they struggle initially, they don't get the answer, there's a little bit of frustration, but it's easy to try, and then to appreciate the value of standing back and talking about what's noticed, because that then leads to a resolution to this problem.
Absolutely.
And maybe we should just say, it is impossible.
It is impossible.
And we'll leave everybody else to go off and think about why it's impossible. And we might come back to this in a future webinar when we're talking about explaining and proving and so on.
That's right. That's right.
But the important thing is giving students the opportunity to struggle a little bit and notice and share what they've done as the springboard to learning.
Absolutely. And again, I think that just to hark back again to the being collaborative aspect that we talked about last time, once more, this idea that actually I've had a go, but look, all these other people have had a go too, and we're all experiencing the fact that we haven't got to 37 yet. That gives me, we've just got many more examples to work with that may lead us to conjecture and generalize. Also, I mean, one of the things that I think you've demonstrated now, this is not meant in any rude way at all, but I think what this problem also encourages is this idea of the messy jottings. You know, I suspect those of you working on this, you participating, you've got scribbles on a piece of paper, which Charlie or I would not be able to interpret at all necessarily, but that doesn't matter because that's all part of your thinking process. And as teachers, we are valuing that as a way of exploring leading into noticings. Now, at this point, I think, Charlie, we ought to go to the website again. So I'm going to stop sharing the visualizer, and now I'm going to go back to the website. And what we're going to do is we're going to share with you now the guidance that we have created, and just draw out a few points for you. We're not going to read it all sort of word for word. So here we've come to the problem solving schools section of the website now. Some of you participating will already be part of our problem solving schools initiative. Perhaps some of you participating have not heard about it before. So do have a little look. If you follow this, and what I'm going to do is go to follow it again and come back to this page so you know how we got there. In our problem solving schools menu, if you're not already aware, you can find out a little bit more about the initiative. But the resources we've created for this webinar, you can find here by going to the resources and professional development link. Now, you'll also find the resources for being collaborative that we created last time. And what we're aiming to do is to structure this page so that as you go down the page, you are supported in those aspects of thinking mathematically, in the order in which we are suggesting that they usually occur as you're working on a problem. So here we go. Here are our new exploring and noticing problems, resources, I beg your pardon, some of which are collections of problems. So here you've got collections of problems, particularly for you as primary practitioners. This page will be the most useful. But we've gathered together some guidance here. I'm going to click on this. And as I said, we're not going to read it word for word, but let's just have a think about the two tasks we've looked at so far. So the Digit Edition and the Make 37. The way that we've structured this page is we've thought, first of all, what are the values? What is it that we truly believe about mathematical teaching and learning? And one of those beliefs, I think, Charlie, which really helps us to support students as they explore and notice, is this idea that actually what we're doing is we're offering a problem
as a starting point.
Right at the start. This isn't about us as teachers teaching something and then students going off to work on the ideas that we've demonstrated. This is about giving students a challenge at the start of a lesson, and as you said, letting them feel a bit uncomfortable and giving them the opportunity to do this messy work. Charlie, did you want to say anything more about that?
Well, in terms of the values and ethos, so I want students to leave, be in the classroom knowing that the ethos is that they get an opportunity to work on problems before getting guidance, that the teacher's going to build on their ideas, that it's not a race to the solutions.
Yeah, that's really important.
And that messy work is an integral part of learning and of doing mathematics.
Yeah.
And so the ethos, whereas I suspect you and I, when we were students, were in classrooms where the teacher got us to, I don't know, underline titles and do everything, and margins, and everything was neat and tidy. And that was the ethos. Yes. And I find it a bit constraining, because I always felt I could only write things that I was sure about.
Sure about, yeah, absolutely.
Whereas we're suggesting that maths can involve a little bit of struggle, a little bit of uncertainty, confusion. But the ethos must be that we must make sure that children aren't feeling anxious about this.
Yes.
So they feel that they're supported, and it's not just those who are very, very fast who are thought of as successful. Yes.
Yeah, absolutely. Okay, so if we're going to have those, those ideas as our values, I guess what we've tried to offer on this page are, first of all, some structural considerations. What is useful to think about in a structural sense? In other words, it might be about the way you organize a lesson. It could be about sort of furniture. And I think in this particular section, to draw your attention to the moment, Alan Wigley's article, which we've linked here, and Ken Ruthven's article are saying very similar things and echo just what we've talked about. This idea that the task comes first, students are left to are exploring, but then actually the teacher's role is very significant. Kenneth Ruthven talks about the codification stage. So the teacher is bringing ideas together that the students have offered themselves. So it could be about offering some particular vocabulary to help students think. It could be about pointing to the direction of a particular result, a particular noticing that encourages everybody to move forward in the journey of the task. So your role as teacher becomes not the demonstrator, it becomes the facilitator. And Kenneth Ruthven's word for this is it's the codification stage of the lesson. The type of task you use, I guess, is key. We want something, don't we, Charlie, that's accessible to the vast majority of students. So our low threshold, high ceiling tasks that we talk about in most of our webinars mean that actually everybody can get started in this exploration, no matter what their current attainment mathematically is. And that's essential, because otherwise the exploration is not meaningful for everybody. So
if we take a problem like Make 37, where we all had odd numbers.
Yes.
What would happen if all our numbers were 1 more than multiples of 3, for example?
Right.
If our numbers were 1, 4, 7s, and 10s,
Yep.
what would happen if we had 10 numbers? What would happen if we had 9 numbers? What would happen? Can we predict what would be special? And we've got a follow-up problem called What Numbers Can We Make?
Yeah.
And explanations about what happens if I've got combinations of numbers which are 1 more than multiples of 3 and 2 more than multiples of 3. Can we make predictions? So we start with a low threshold,
Yep.
all odds, but we have
A high ceiling.
a high ceiling because we can get students asking more, get involved with more difficult questions.
That's right. That's right. And so if I just scroll down a little bit further on the page, the final section of the guidance that we're offering is more about those nitty-gritty interactions in the classroom. Charlie and I have both read recently Peter Leodell's, well, he's written a book, 14 Practices for Building Thinking Classrooms in Mathematics, which we would heartily recommend. And there are a few of these practices in particular are applicable, especially to exploring and noticing. He also talks about the timing of introducing the task. He also offers advice, though, Charlie, I think, doesn't he, about the exact way in which you introduce a task and the kind of questions that teachers answer and the way that they interact with students. Yeah,
absolutely.
So this page, as I say, we're not going to read it in detail, but we hope that by creating this guidance, you and your colleagues can go and read what we've put in more detail. We're offering suggestions, that things that we've read that we have found useful in the context of exploring and noticing. We're offering you these links, more to think about, in the hope that you will also find it useful, and particular points will resonate more with some of you than others. Shall we do
and just those 3 headings are enough in terms of the ethos and values informing the structural considerations about how we plan our lessons, how we structure our lessons, what kind of activities we use, and then the more nitty-gritty to do with the interactions and how these influence or how these help us promote, encourage students to work in this way.
Absolutely. So I think we should do another task.
2 more in 12 minutes.
Not sure we'll have time for the 4th one, but anyway, let's do for the 3rd one. Now, we've chosen this one particularly, and I think it's really important to say this, is because this is an opportunity for you to really put your shoes in the problem solver's position, in the mathematician's position. So we've given you a task that we know is challenging, but this is a really good context in which we can explore for ourselves. So we're going to introduce the task using the visualizer again. So let me share again. Here we go. Okay, so Charlie's got 4 boxes here, and Charlie, could you pop 4 digits into each box? Digits 1 to 9 inclusive. You can repeat a digit if you'd like to.
Can I use 0 as well?
Why not?
Okay, and I can repeat. So
yes,
I'm going to put
if you want to.
2, 4, 7, 4.
Okay. So what we're going to do from these 4 digits is we're going to read out 4 2-digit numbers. So reading along the top row, we've got 24. If you wouldn't mind just making a note of that, Charlie. Yep. Along the bottom row, we've got 74. If we read down the left-hand column, we've got 27. And reading down the right-hand column, we've got 44. So we're going to find the total of those 4 2-digit numbers. So Charlie, what does that make?
169.
Oh, that was fast. It's not about speed. Okay, so Charlie, you've made a total of 169. My challenge to you is, can you use any 4 digits like that, with repetitions should you wish, but the total of the 4 2-digit numbers that we create must be exactly 200. So Charlie, we're going to have a think about that. It's over to you now. Can you find 4 digits when arranged in that way? Give us the four two-digit numbers that make a total of 200. If you find any solutions, could you please post them in the chat? And I suggest that maybe you post them in order, top left, top right, bottom left, bottom right. So in this case, I would have written 2474. Thank you, Charlie. So let's give you a little bit of thinking time. Any solutions, please do pop in the chat. Thank you so much to those of you who are posting solutions so far. As a little reminder, would you mind writing your solution as 4 digits going top left, top right, bottom left, bottom right? Charlie is kindly,
the first one.
yeah, there's a little reminder. So Charlie is just showing us there that 24 at the top, 74 at the bottom. We could post as 2474. Thank you so much. Charlie's collecting together some of our solutions. Thank you, Charlie. Let me leave you to think a little bit more. thank you to those of you who are continuing to post solutions. Just to be slightly annoying, if you haven't already had a look, perhaps have a little look at the solutions we've now gathered. Charlie has been, as they've been coming in, Charlie has been sticking them onto this piece of paper. Charlie, you seem to have put these in particular places, perhaps. I was interested, I wonder if you would like to have a little look at what Charlie's done. What do you notice? What's the same about these solutions? What is different? I noticed that somebody, I think it was Eileen, posted when Eileen put her solution in, they said, I used clues from above, which is quite intriguing. Some of you are writing some of your noticings. And I like the fact that some of you have put question marks at the end of your noticings, which indicates that tentative nature of them. We've got some noticings about number bonds to 10. We've got noticings about a total of the row is one more, one less than the other. I wonder if what Charlie has done here might help us to generate some more solutions. Does the fact that there is a gap between two solutions mean that there's room for a solution there? Is that indicating a missing solution, I wonder? I'm afraid that we're running out of time, Charlie.
Okay.
I wonder whether your role has been very particular here. You as the inverted commas teacher, I wonder whether you could say a little bit about your role for this particular problem.
So I think the patterns are much more obvious if I organize the solutions that have been coming along in a particular way. And it started being messy because people randomly came up with solutions, but then little by little, some solutions appeared next to others, for example. So I'm filling in one of the columns, and there are similarities between solutions which appear in the same column, and there are similarities between solutions that appear in each row. And eventually, we can end up with something like the one that I had prepared.
Which now has lots of gaps in it, but yeah, the combination of those. So again, we're running short of time, but this is a fantastic problem for working on as a group. And those noticings become more apparent, and yeah, it can be a springboard for all sorts of discussions. This problem, in fact, I haven't told you what the problem is called. This problem is called reach to 2. No, it's not. It's add to 200. Add to 200. This one. Sorry, Ali. Thank you for the prompt. I am going to wrap up now because we're already a little bit late finishing. Charlie is still beavering away with these. We hope that you've got a good sense of this idea of exploring and noticing and really giving students a chance to do that mathematics, that discovery for themselves. I'm going to stop sharing the visualizer, go back to the website just to wrap up. Mhm. Oh dear, what am I doing? Website. Here we go.
So it seems important that they have that messy.
Yes.
There is a chance for the teacher to do some codifying and helping sort out what's happened.
That's right.
But then this is the prompt to, why are these things happening? Why do we get something similar happening on all the solutions that appear in the same column? Why do things change as you go across? How do things change as you go up and down? How do things change? Is the source for some interesting mathematical thinking.
Absolutely.
Which we're not going to do now.
We're not going to do now.
But we might come back to.
We'll leave you to think about that.
Or you might want to work on with your classes on this problem. And our problems have got teachers' resources.
Yeah.
And this is an old problem, so solutions have been published.
Yeah.
So you may want to look at it. And the invitation that your role might be to gather the solutions as they're coming along and help to organize them. We've worked with a colleague who uses blue tack and uses big sheets on the wall.
Exactly. So just a quick reminder, here is the problem solving schools page. The resources we've been looking at today, you will find in the resources and professional development page. Everything is free to access, no logins required. So the guidance we've been talking about is this resource here. We'd like to just finish by saying thank you again to Trinity for funding our webinar. If you have, we would really appreciate your feedback. Ems, I don't know if you've already popped the feedback form link in the yes, you have. Thank you so much, Ems. Do give us your feedback, and then we can try to make these webinars as good as they can possibly be. And I think
I just want to mention one last thing.
Go on.
Only because I only read about this very, very recently.
Oh yes.
And I just thought it captured what we're trying to do. And it talked about how a lot of students' experience of maths is fossilized maths, which has all been thought about, tidied up, done and dusted, and it's presented to us. And students' experience is rather dry. And I suppose our intention is to bring maths to life with rich tasks, which are engaging, which involve the students, which give teachers opportunity to build on students' ideas.
Yes.
And we hope this today has given you a flavour of what it might be like if you want students' experience to be active and engaging and purposeful.
Exactly. Thank you, Charlie. Great summary. Thank you all very much. We hope to see you again at a future webinar, and have a lovely rest of your day. Goodbye.